Thanks. It's great to be here, and I thank Chris for taking 5 minutes because I'm going to take 25 minutes. So these trips actually are very enlightening. You know how people see Open RAN across the world, and what I hope to do in the next 15, 20 minutes is really give you a real live update of what's going on. And it's clear that information sharing between countries is absolutely essential to get the real true facts of what's going on in the marketplace. So firstly, I'm going to talk a bit about the ecosystem, and I think for those of you that follow me on LinkedIn, then these charts are all available, and they'll soon be on the Open RAN Alliance website in the next week or so. The Open RAN Alliance has adopted these charts, but this really is the ecosystem for Open RAN, and I think the real message is, look, 5 years ago, this did not exist. Right, 5 years ago, we were in a closed market space, 2 trusted vendors, a couple of untrusted vendors, and now, what we've got with Open RAN is all about innovation. And Open RAN really started with the thrust of the operators because the operators wanted choice, right? And you hear about, it's very easy to say, okay, I want single source, I want everything from one vendor, right? But every operator in the world gets everything from one vendor, every feature from one vendor. There's no competition, there's no innovation going on in the marketplace, and that's what Open RAN actually brings to the ecosystem. It's about innovation, competition, and I would say co-opetition, because I think one of the things that we found in all of this, there is no finger pointing between vendors, right? Vendors get together, solve the problems, go compete in the marketplace. And I think there's probably 10 people in this room that will say the same thing, that Open RAN is about working together, sharing knowledge, and growing the ecosystem. So, quickly, I won't spend too much time on this, but you can see the Open RAN, is broken down into, all the government initiatives, the vendors, the core infrastructure providers and silicon providers, and then down on the bottom corner here is all the integration test labs. And I think, as of today, with all the funded labs that are coming together, without taking into account the vendor labs, we have over 21 labs that are testing Open RAN today. So there's a huge sums of money being invested in this ecosystem. And I've got to say congratulations to Taiwan. If you look at this chart, there's as many suppliers coming out of Taiwan almost as there is coming out of the United States. And I think the new vendors that I found over the last few days is going to probably bring this up to about 37 vendors in Taiwan that are coming out to support the Open RAN ecosystem. So the technology is here, the knowledge is here, right? What it needs is exactly what's happened in the United States is operators to pick it up and support the local companies to really bring the ecosystem to life. Now, I put this slide in, and I everybody talks about, well, but the, Open RAN is dead, it's not happening. This chart actually shows for the first 3 years, and it's animated, the countries that signed the 5G contracts, right? So if you go back to 2018, back in 2018, there was only 12 5G contracts signed, and that was pretty much the Americas and a few other countries. Now, with the signing of contracts, there's actually a period of about 6 years that you've got to say, look, that operator is locked to that vendor, right? And you saw the first occurrence of these contracts being broken when AT&T signed the new contract with Ericsson at the end of last year. So if you run the philosophy as these contracts start to come available during 6-year periods, we're right at the front end of a new wave of contracts that will start to come available. So, I think from we're still in a tough market. There's still a lot to do. But if you say, look, in 2021 timeframe, there was 196 5G contracts. You're going to see those 196 contracts come up for renewal. And that's the opportunity where the operators will start to look at, do I need to bring in new vendors? Is it going to be non-standalone? Is it going to be standalone? So, I'm going to dig further into this, and I'll publish it with my other charts in terms of the operators. But you can see, that today there's 792 5G contracts out there, which eventually are going to come up for renewal. And that's the opportunity for Open RAN to be taken in and operators to switch from non-standalone to standalone going forward. So let's talk about Mavenir. So we've got a short video here for.
Why not have the best?
Come without my video.
Create a modern network that can support millions of subscribers with reduced CapEx and OpEx. Now you can. The future is open. Open RAN is an approach that is driving innovation and interoperability, producing more secure networks through open standards and compliance, and giving operators freedom of choice in designing and building their networks. Mavenir is a pioneer in Open RAN network architecture, deploying the world's first fully containerized, virtualized, and open network. It leverages open interfaces, virtualization, and web-scale containerization to support any deployment scenario, covering all cloud architectures, private, hybrid, and public clouds, expected to result in nearly 40% savings in TCO over 5 years. Mavenir's RAN Intelligent Controller, or RIC, helps manage multi-vendor RAN components and enables operators to proactively manage their network resources to automate processes, mitigate service degradation, and maintain the best quality experience for their subscribers. As a proven innovator in virtualization, Mavenir continues to lead the market in developing the future of networks. Mavenir, trust the future.
So that's a short advertisement on Mavenir, but in reality, we've been in the soft switch business, the software business for virtualization for over 15 years now. And over the last 7 years, even before the O-RAN Alliance was formed, we really started this challenge in terms of building an open RAN architecture and really taking away the barriers for the industry. Our first association in the radio was actually with MTI here in Taiwan, where we did the very first Open RAN radio with Facebook for the Evenstar program. So that was one of the very first open radios that we actually integrated. So if you can see from a portfolio perspective, that the whole platform is built on the premise of open compute, open interfaces, and interoperability with the vendor ecosystem. So you can see the key partners that we have there for certain elements, but this platform will support 2G, 4G, 5G, and we are being asked to deliver 2G today into networks where 2G will never go away for some of the operators. But it has all the functionality that is needed in terms of comparison of features. We've done integration with brownfield, and obviously we've done greenfield networks. But it's a platform for the future, and I think one of the things that was talked about this morning was 6G. Well, this is a 6th generation platform, right? There is no tie between the software features of the RAN network to the platform architecture. And you can see that because the fact that we're running 2G on a 6th generation architecture platform is really speaks to the power of what's being put in place. And therefore, software and hardware have become completely disaggregated from each other, and 6G will become a set of software features primarily on the same compute platforms and hardware going forward. So in the sense of investing in an Open RAN platform, is sort of a necessary step, one, to get the cost and license structure sorted out in the networks to become competitive, allow innovation, and then be ready for some of these 6G feature sets, which from an operator perspective, you can develop yourself, right? You don't have to have a big vendor come in and say, wait 18 months to give you a set of features. You can bring in a software house, a local software house, develop the features, deploy them into the network, and really differentiate yourself on an operator by operator basis. You do not need to be, every operator does not need to be a clone of each other. And I think this really opens the market for competition and differentiation from the subscriber level. So in terms of collaboration in the ecosystem, and I really say this is more about co-opetition. Vendors cooperate, they integrate their products, and then we go compete in the market space. And you can see from a silicon perspective, we've worked with, we're primarily started off with Intel on the FlexRAN platform, but we've developed with Qualcomm, NVIDIA, Marvell, and also Leapfrog is a new startup in the space. On the radio front, this is a selection of radio logos, but we've integrated with 14 plus radio companies now on the Open RAN interface. Now, why so many radio companies? Well, if you look at the number of radios that you need on an annual basis, I think it's about 152 different frequency bands are needed every year, right? There's no one vendor coming into this space can actually take on the challenge of developing that number of radios. So you're going to have to rely on other radio vendors to make up the market needs. And then platform-wise, so this is a web scale platform and it could be hosted in the web. Now there's some constraints on what we call the DU, which is the piece that sits at the cell site. It needs to be close to the cell site or within 10 kilometers of cell site, but everything else can be hosted in like Amazon. And Mavenir today has all the products in the Amazon cloud, and operators like Dish are using it that way. And then server technology, based on Intel platforms, various choice of platforms. These are all open market, off-the-shelf compute hardware. There's no customization going on in there. Now, we've been working with Quanta here in Taiwan to really get the cost out of the platforms and come up with really low-cost platforms for DU. And that product, I think we launched at Mobile World Congress as a leading-edge product for the Open RAN marketplace. So I put this up and really, again, this is all about learning. But some of the key logos that Mavenir is working with, and I'll talk a bit more about Dish and Paradise in a moment. I've got them on separate slides, but if you can follow the, I don't know whether this works. The mnemonics on there is like, here's 5G. It's in the Amazon cloud. It's using VMware. We've integrated with Fujitsu radios. And this was the first network where we had voice over new radio. So, but I'll talk a bit more about Dish in a minute. But if you look at this, Airtel in India with massive MIMO, and doing non-standalone networks with Band 1 radios. These are all live networks today carrying commercial traffic. These are not trial networks. The deployments are in limited scale, and that's all more due to the ability for these companies to finance some of these deployments. But these two on the end here are actually new applications that are starting to come out in Open RAN. So NTN, we've got making live voice calls with Legato, using an Open RAN architecture to supply end-to-end NTN for narrowband rural coverage through satellite, and then recently with TerraStar in Canada for 5G IoT. Again, on an Open RAN network. And then, talking about the big logos as entry tickets, well, here's some big logos. T-Mobile, Germany, VMO2 in the UK, Bell Canada, Vodafone India. They're all real live deployments that are going on. And actually, in terms of Vodafone UK, we were actually in Vodafone 4 years ago, and I think we've actually got more sites in Vodafone today running open networks than actually Samsung has. So I'll just push that one a little bit. But Vodafone India obviously is going through some financing, but we've got 4G, 5G there now. In telecom in Hungary, they want 2G, 4G, 5G, all running on the same platform. So this gives you sort of the scope of some of the things. And last but not least, in Australia, there's a very strong distributed antenna market for in-building coverage. And by employing Open RAN on the DAS networks there, removing over 75% of the energy consumption that is wasted due to having base stations sitting in base station hotels for the DAS market is really changing the game for in-building distribution systems. And there's further improvements that will go on with the DAS products. The DAS products will become more very low power remote radio heads. But today you could go to all of your existing DAS installations and replace it with a DU, a low power radio, and remove all those base stations that are sitting up there hogging energy and hogging capital expense. So Dish, and we've got Svetlana from Dish here, and she talked a bit about it. But Dish actually is, the largest deployment of Open RAN in the world. And the reason is that, they have 20,000 sites deployed today, but at those sites, there's actually 15 radios per site. So the software for 10,000 sites is supporting 150,000 radios. And that's the bit that gets lost in this, that the complexity of the Dish network is such that I don't think there's any network of that size carrying that sort of capacity. And the reason that was done is Dish was very clever in about how to use Open RAN, because what they took is like 5 spectrum bands that could not be used individually for 5G. And they took those 5 FDD frequency bands and through carrier aggregation produced enough spectrum so that you could get 100 megabits down, 20 megabits up, which was a condition of the license. So what Dish proved is that not only could you use Open RAN, but you could take old spectrum and start to reclassify it for use in a 5G network. And so that was sort of the art of this. And to that extent, we've been doing 5G carrier aggregation since the launch of the Dish network almost over a year ago. So, this Dish network actually as well, the speed at which it was built, we've done integrations with Fujitsu Radio. We integrate, MTI is another supplier for radio into the Dish network. And then the other pieces are actually built in the cloud. So, in a sense, from an operator perspective, they don't own data centers, they don't own, NOCs and stuff like that. It's all relying on Amazon Cloud to do this. And to the extent that, everything is automated from software download to the cell sites, we were doing over 1,000 cell sites a day in terms of integrating and bringing it up on air, because there's no people that have to go out to the cell sites. It's all fully automated. And they essentially built that network with 10 people downloading software into all of those base station elements. So in a sense, we built 10,000 sites within 16 months. And as Savannah said this morning, 70% of the population is covered in the US with 5G service. The network has been qualified by Apple for iPhone, and I don't know if people are aware that actually to sell the iPhone in a network, Apple has to qualify the quality of that network. So Apple did their own independent testing and verification of the Open RAN network in terms of features and functionality. So that's an independent view of the quality of Open RAN in terms of allowing that iPhone to be launched. And, again, there was a mention about TCO, but the TCO benefits through building an Open RAN network like this have seen, better than 30% TCO savings, which has been predicted from day one that would be achieved in actually doing this. So this is the largest Open RAN network there. It was one of the first with voice over new radio. So again, that was a new step forward. Now, the thing that's really come out of this is, why do I need a non-standalone network? You talk about 5G, actually the break between 4G and then going to 5G standalone is a chance to clean out all the existing vendors, all the existing licenses, all the existing costs, and start afresh. And actually that's what a lot of operators are now looking at, is they're looking at a fresh build of a 5G standalone network to clean out all the bad habits, if you like, and all the bad technology that's been sitting around in their networks for years. So, I think, the 5G standalone build is stored in terms of the old vendors, but I think you're going to see it pick up once Open RAN really starts to move forward. The other one I put in here for reference is, all of this is scalable. So, there's discussions about enterprise networks and small networks. Now, from a Mavenir perspective, all the software is scalable. So, if I support 1 million subscribers at one end, for say, I can support 10 subscribers down the other one. It's really just down to, capacity of servers and the cost of servers to actually go do this. Now, this was a network we launched in Bermuda with an operator called Paradise. And it's essentially being provided as more of a fixed wireless access type solution. But, the key here is gigabit download speeds, and it's actually there as it's got massive MIMO, 64T, 64R, and there's been all this discussion about Open RAN can't support massive MIMO and all the other various noises you hear in the marketplace. Yes, massive MIMO, performs just as well on Open RAN networks as any other networks. And continual improvements will go on with massive MIMO through the O-RAN Alliance, but there are no barriers to any of the technology that's needed in an Open RAN network today. And the statistics KPIs that we see back from our customers are showing equal performance for Open RAN versus closed RAN. So, in a sense, it's really don't believe everything you hear, right? You've got to ask the questions, transfer the knowledge, and the real facts are out there. And with that message, I really encourage Taiwan to really pick up and launch a macro Open RAN network. And the first operator that does that will have a true vehicle to compete really head on in the marketplace and win customers with new features and functionality. So thanks for the opportunity. I'm around for the rest of the week. So, I'm happy to answer questions at any time. And I think a lot of you know how to get hold of me on LinkedIn, but it's great being in Taiwan. And I really do thank the ability to exchange information and bring everybody up to speed.